Good evening, y'all, and welcome to another night of algebra with Miss Sapno. Tonight we're doing lesson 2.6, so go ahead and get out your daily note-taking guide. We're going to be on pages 40 and 41 this evening, and we're talking about working with formulas. Let's just review some terms really fast. Let's look here. An equation is a math sentence that uses an equal sign. A math sentence is just simply something that has numbers and equals and maybe one variable. So 9 plus 2 equals 11 is an equation. 9 plus x equals 12, or 9x equals 10, or 9 over x equals 81. Any of these are considered equations because I have numbers and or I can have a variable. And I have an equals. You always have to have an equal sign for there to be an equation. This is important. Okay, so let's look down here. A literal equation. What's the difference between an equation and a literal equation? Well, a literal equation is a math sentence. Okay, so far it's the same as up here. That uses an equal sign. Okay, so we're talking an equation. And it also has to have two or more variables. Oh dear. So literal equations are literally a little bit more challenging. They could look like 9 plus x equals y. I have an equal sign, I have a math sentence, and I have variable 1 and variable 2. Now they might even be on the same side. What if it's 9x plus 3y equals 12? Oof, this looks really yikes. Let's look at this. I've got variable 1 and variable 2, so I meet this criteria. And I've got an equal sign, so it's an equation, and I have a math sentence here. All right, so literal equation is just taking equations that you've already been doing, like these, and it's just upping the ante and making them a little bit harder. So let's look at making literal equations and solving problems. If you're on page 40 of your note-taking guide, let's look at example number 1. All right, this is where you have a geometric formula. This is asking you to solve the formula for the volume of a rectangular prism, and they give you your formula, and they ask you to solve it for width. This part is critical. That's what I'm solving it for. And it's in terms of its volume, length, and height. Okay, well, let's think this through for a second. Remember that my, if I want to find volume of anything, this is a little mini geometric lesson on the side here. Volume is always going to be the area of my base times my height for anything, any kind of object. So if I have a rectangular prism, the area of my base is this area right here, which is the same as what? Well, if volume equals base, this is my base area times height, and my base area, it's a rectangle here. So how do I find the area of this guy? Oh, it's just length times width. So my volume for a prism is going to be length times width. If that equals b, I'm going to plug that in, times height, or length times width times height. Now, if I have a cylinder, the area is, I have to find, remember that volume equals the area of my base times my height. Well, the area of my base equals what? Oh, look at this. I've got a circle over here. How do you find the area of a circle? Well, remember that a circle is just pi r squared. So the volume for a cylinder would be pi r squared, because that's my base, and my volume equals my base times my height. And in this situation, your height would be this guy, this part right here. So I would take the area of my base and I would multiply it by the height, and it would tell me how much liquid I could fill in this jar. Okay, so now that that little mini geometry lesson is done, let's come back over here to my problem. This problem is asking me to solve the formula. All right, my formula is the volume of a rectangular prism, which it gave me here as length times width times height. And it asks me to solve it for width. What does it mean to solve something for something else? Well, ultimately, it means that what I want to have happen is I'm going to have W equals something. So I need to end up transforming this formula so that my W is by itself on the side of the equals, and that V, L, and H are all on this side. I have to move some things around. So you've done this with numbers before. If I have 9x equals 3 plus 4, and I've got this extra 2 over here. How do I do this? Well, if I want to get x by itself, I had to subtract 2 first off, and I had to do it to both sides. And that gave me 9x equals 7 minus 2, which meant 9x equaled 5, and I divided by 9. So we're going to do the same process over here. All right, so we're going to try canceling out my L and canceling out my H, leaving just W. But that means that if I divide this side by L and H, I've got to divide this side by L times H. So what does that leave me? Well, it leaves me with something that looks like W equals V divided by this product of L times H. Oof. All right, notice that it doesn't matter. I could end up reversing my W, and I could put W on this side and have V over L times H. This is the same thing as this, okay? So what is, if I'm solving it in terms of volume, length, and height, it means that if I wanted to find my width, I would need to take my volume and divide it by the product of my length times height. Now, what if this problem had asked you to solve the formula V equals L times W times H for, let's say it wanted to solve it for length. What does that look like? See if you can figure out how to get length equals something. Pause me and then let's check your answer when you're done. All right, welcome back. Let's say if I want to solve V equals L times W times H, and I want it to be in terms of length, then I've got to get length equals. So I first notice that I'm multiplying here, so I have to do the opposite of multiplication, which is division. And if I want to keep L, then I'm going to keep L here, and I'm going to divide by W times H. What I do to one side, I've got to do to the other. So I end up with my W and my H crossing out, and I get V over W times H equals L. Now, remember that 2 plus 2 equals 4. Doesn't matter if I have 4 on this side or the other side. It's still the same thing. So if I want to put it like this, then that is simply L equals V over the product W times H. All right, good job with this. Let's look at one more situation where we have only variables, but this time I've got addition or subtraction going on. If I'm looking at this one, still on page 40 of my note-taking guide, go ahead and follow along with me. I am solving Z minus BR equals P, and I want to solve it for B, and I want it to be in terms of ZR and P, which means if I'm solving for something, solve for whatever means that it's this, that is the same as this, equals dot, 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 dot. So in this case, if I'm solving for b, I want it to be b equals something else. So I want to get b by itself. All right, so if I'm looking back over here at this equation, what do I need to do first? Remember those 5 things I said? The first thing was to get away fractions and decimals way back when. Yeah, well, I don't have fractions and decimals, so I don't need to worry about it. The second was distributive property. I don't have the distributive property, so I can move right into the next, which was to combine like terms. Okay, do I have any other z's or br's or p's? Nope, they're already combined. So my 4th step was to look at undoing addition or subtraction. Okay, so I have to look here. I've got a positive z and I've got negative br. And if I want to keep b here, then I'm not going to do anything to this term. I need to move this guy. So how do I get z away from my b? Well, hopefully you notice that if I'm subtracting br from it, then this is positive. So I end up needing to add a negative. So I'm going to do z minus br equals p. But I have to subtract a z from this side too to keep my equation balanced. So my z's end up crossing out. I'm left with negative br equals p minus z. All right, hopefully you're with me so far and the baby isn't distracting you too much. Now, I want to solve for b, which means I need to keep b here. So I don't want to move my b, I need to move my r. So how do I move my r? Am I adding, subtracting, or multiplying and dividing? Hopefully you recognize that br is the same as b times r, so I'm doing multiplication. That's the 5th step. That's the next to last thing I do. So now I can divide the product of b and r by r. What I do to one side of my equation, I've got to do to the other. So my r's cross out, and I'm left with negative b equals p minus z over r. Fantastic, except I have a negative b, and I want it to be solved for positive b. So how do I get this negative 1 away? I've got to divide by negative 1. All right, well, I got to divide this by negative 1. Ooh, this is no fun. Well, hopefully you recognize that negative 1, if I'm dividing a fraction by this, I've got to switch what's going on over here. And really, negative 1 is the same as negative 1 over 1. So even if I switch it, it's still negative 1 over 1. So we are going to do b, because dividing a negative by a negative ends up crossing out my negative, equals p minus z over r times negative 1 over 1. Okay, now I can just multiply through, and this is distributive property. It's got to go to both. So negative 1p minus negative 1z over 1r. Let's simplify this a little bit. Negative 1p minus a negative becomes positive 1z over 1r, which if I get rid of my 1's becomes negative p plus z over r. And that is what b equals. It doesn't look pretty, but you have solved this equation up here for b, meaning that it's b equals some combination of z, r, and p using this relationship up here. Well done. At this point, I'd like you to check your understanding with the problem number 1 at the bottom of page 40. Show all of your work, and we'll check it tomorrow in class.